Alaska presents unique infrastructure challenges unlike any other state in the US. From its geographic context, harsh climates, and economic factors, infrastructure owners need to creatively plan and adapt to various obstacles that impact their ability to deliver services. For example, many remote communities lack safe and reliable infrastructure systems due to their isolation and added complexity of the subarctic and Arctic environments. Covering over 663,000 square miles, Alaska's sheer size creates a unique obstacle to managing assets. The logistical challenges of getting the needed people, equipment, and materials to and from communities adds complexity to planning and additional cost to service rural and northern regions. Alaska's remoteness is unparalleled, with 86% of communities unreachable by road. Many communities rely on air and water transport. Airports and ports are crucial for supply chains, but require constant maintenance and upgrades to handle increasing demands and climatic inputs. The lack of road connectivity also complicates emergency management and supply delivery. However, the high cost of building and maintaining roads in rugged and remote areas, combined with limited funding, often require additional community contributions, straining local resources. Despite its expansive territory, Alaska's population is relatively small, with just over 730,000 residents. Many communities are remote and isolated. They rely heavily on infrastructure for their well-being. But what happens when changes in populations don't support the current infrastructure capabilities? Let's look at a recent example. The population in Murtarvik increased from just over 180 to nearly 230 due to the construction of new homes for families relocating from Nutuk, where melting permafrost has rendered the land waterlogged and sinking. During a recent cold snap, the community's generator was overloaded, leaving them without electricity for more than 3 days, which caused the water plant to freeze. This situation demonstrates how infrastructure can easily break down when faced with population changes and overloading, and the importance of planning ahead to account for these challenges so that it doesn't impact the current level of service provided to residents. In addition, the state is experiencing migration loss, aging populations, and loss of skilled workers as highlighted by Alaska's Department of Labor and Workforce Development Research and Analysis. Alaska has experienced lost population for 11 years to net migration, where more people have moved out of the state than moved in. Rural areas migration has turned increasingly negative so far this decade. With lower populations in these communities, the cost per person grows higher to account for the budget needs used to maintain infrastructure. The working age group has previously kept Alaska's net migration positive, specifically from the 20 to 39 age range. But from 2018 to 2023, this age range has gotten smaller from 25 to 34. As of February 2022, there were 2 job openings for every job seeker. This research emphasizes the high demand for workers. This has led to low labor availability and required qualifications of people to do the work. Alaska's Workforce Investment Board and its partners, Kinetic West, conducted a survey in 2023 to investigate Alaskan employers' challenges. The findings showed that the most challenging roles to fill included, not limited to, qualified tradespeople in technical positions, finance, operations, and specialized positions. There are less qualified workers and high employee turnover, further delaying Alaska's communities from achieving their infrastructure goals. Alaska's severe weather conditions, including extreme cold, heavy snowfall, ice, and permafrost, require specialized designs and unique operating and maintenance demands to avoid rapid deterioration of infrastructure, such as roads, bridges, and buildings. Due to Alaska's location on the Pacific Ring of Fire, earthquakes and volcanic activity are constant threats, further increasing the demands of infrastructure and requiring advanced risk planning. During 2020 to 2023, there were 11 major disaster and fire management assistance declarations in the state of Alaska that ranged from severe storms to landslides. Additionally, escalating temperatures contribute to various environmental changes, including wildfires, rising sea levels, changing weather patterns, heightened precipitation, flooding, erosion, diminished river and sea ice, and the degradation of permafrost. Permafrost exists throughout Alaska and has been relied upon to provide a solid foundation for buildings, roads, and pipelines. Increasing ground temperatures from local activities and climate change are leading to permafrost melt, which is putting these foundations at risk. Specialized designs are now required to prevent infrastructure-induced thaw, and costly modifications and repairs are inevitable due to permafrost sensitivity. An example of how this is affecting Alaska comes from Hooper Bay. One of the major disasters declared in Alaska was in 2022 at Hooper Bay. The sewage lagoon breached, leaking into the surrounding tundra, which caused worry about food security. When the Hooper Bay mayor, Sandra Hill, was asked about the possible cause of the breach, she mentioned that the permafrost beneath the lagoon had melted, destabilizing it. In recent news, researchers from the National Park Service, the University of California at Davies, and the US Geological Survey found that the thawing permafrost was changing the color of Alaskan rivers and streams from clear blue to rusty orange. Discoloration and cloudiness are being caused by metals such as iron, zinc, copper, nickel, and lead, some of which are toxic to the river and stream ecosystems as the permafrost thaws and exposes the waterways to minerals locked away underground for thousands of years. As you can see, melting permafrost can impact public health as well as infrastructure in your communities. But what are the associated costs of permafrost decay? The Northwest Territories in Canada, population of around 40,000 people, deals with similar challenges. There, the NWT Association of Communities, Enviroeconomics, and Tetra Tech conducted research to better understand the associated cost of handling permafrost impact. Their findings estimated that the total cost of the permafrost impact on their assets in the 33 communities was roughly $1.3 billion Canadian, which is equivalent to just over 900 million US. In addition, they found that on an annual basis, the economic losses are roughly $51 million, which is the equivalent of just over $37 million in the US. Effective infrastructure planning requires the knowledge of permafrost distribution and future climate impacts, with various agencies collecting relevant data. Coordination among these entities is essential for assessing degradation's impact and planning resilient infrastructure and budgeting for the costs. Alaska relies heavily on revenues from the oil, natural gas, minerals, and fisheries industry, as it lacks state income or sales tax. In 2020, oil revenues accounted for over 2/3 of the state's budget, leading to funding fluctuations for infrastructure projects. However, oil production in Alaska represents only 4% of total US production. The decline in oil production and prices has strained the state's budget, impacting maintenance and new projects more severely than in states with diversified economies. Efforts to diversify the economy have been slow, but are crucial to mitigate risks associated with heavy reliance on oil revenues, stabilizing revenue streams, creating jobs, and fostering sustainable growth. Fisheries and tourism collectively contribute to 15% of Alaska's economy, roughly $8.6 billion, and yet ownership of the harbors that these industries rely on were transferred to local governments in the 1990s. Maintaining these key employers and sources of income rely directly on maintaining the condition of harbors. While the state has helped match community investment and renewal, if this funding stream disappears, local governments will need to work even harder to maintain this industry. As Alaska tackles its unique environment and geographical challenges, strategic planning and resilient infrastructure design will be essential for assuring well-being and prosperity of its communities.